All right, let's get started. Thanks for coming here. How are you guys feeling today? It's been pretty silent on the other talks that I attended. That's not going to be useful either for you nor me. How are you guys? Very good. All right, let's get started. Hopefully, you learn some things out of this, and from your questions, we can learn some. So the topic today is Hadoop Yarn 2015. This is the annual ceremonial talk that I give. There's always a present, there's always past, and there's always futures. Hopefully, there's always future. So, who are we? I'm Vinod. I'm a long-term Hadooper. I've been working on Hadoop, various parts of Hadoop for nearly 8 years, 2007. I'm a committer in PMC, member at Apache. Previously, I was part of the Yahoo Hadoop team. Then we came to Hortonworks. I've been leading the Yarn team since day one. And with me is my team member, Jian. Again, long-term contributor, responsible for all things Yarn. He would not quite agree to this, but he's one of our star developers. So let's start with this. Every summit, I've been doing, like I said, I've been doing this talk for a while, but every summit there's a bunch of folks who are coming for the first time here. They want to know what this is about. They've heard a lot about Yarn, and they've been yarning since. So let's do a quick overview of what, why, and why this is all useful for you. To really understand what Yarn is useful for, we need to understand how the data architectures are evolving over time, right? The traditional architectures, they were centered around specialized systems, silos, and the silos usually tend to be managed separately. Security would be implemented separately. They would be governed separately, and so on. Clearly, that's it works very well for the use cases that they focused on, but they have limited scalability, limited cost efficiencies, and so on. The new architecture for the present and the future, we are moving to centralized systems, but yet a distributed system, so you don't have the scalability limitations. You get very good utilization. You get cost efficiencies. You can enforce org-level policies in a central place instead of doing a piecemeal job in the siloed architecture, right? So that's how we modeled our present-day architecture. Pool cluster resources in a central place and have your data storage system using Hadoop's distributed file system. Once you have data in a central place, the next thing to really focus on is how to extract value out of that, right? Data tends to be owned by different sets of people, owned by a different set of people, and that itself changes over time. People have their own applications. Different types of users have different types of applications, and so on. Managing this is actually a messy problem, right? If you do it in an ad hoc way, you'd not scale fast. In the centralized architecture, you need a different way of managing your apps, their life cycles, their versions, and so on. There's also the multi-tenancy problem. Typically, when we talk to a lot of users, they start with a 3 or 4 node Hadoop cluster, and they say, hey, this is good enough for me. I've got enough data. I've got my 1 or 2 apps that I want to run on this cluster. But it almost always never stops there. Data has gravity, right? As you get more data, value out of the data, more data tends to come into the cluster. You get more applications, and so it scales up fast, both in terms of the data size, in terms of the application variety, and it also scales in terms of the number of users, different use cases, et cetera. And when different people come in and participate in a central cluster, you need multi-tenancy to make sure they don't fight each other, right? So good models for sharing isolation, they're needed in the centralized architecture. And like I was mentioning, if you try to do it in an ad hoc fashion, it might work at a small scale, but it gets unmanageable really fast. So that's the part in terms of applications and users. There is also this is one of the biggest problems that we see everywhere. People might agree to run in a centralized architecture, but then once you do that, different set of people have different expectations and end goals. The administrator says, I want maximum utilization, I want best use of my cluster, I want a good return on investment, and so on. But users have different goals, right? So some users say, I don't care what your goals are. I want the entire cluster to me within the next 5 seconds so that I can do my job and go away. Somebody else says, I want everything right now. Somebody else says, I want access to all the data. I don't care about your security goals. the more access I have to different data sets, the better I can implement my use case, right? So there are various expectations from both the sides. Users want everything faster, better, access to everything, etc. Admins want to control in terms of how you utilize resources, how you get more out of the cluster hardware, so he can go and turn around and talk to his CX officers to expand the cluster depending on the value that he's getting out. So that's where we get Yarn into the picture. So the goal is to store data in a central place, interact with that centralized data in multiple ways, be it different users, different application paradigms, different frameworks, etc. And different from the traditional architectures, you can scale it as you go. If you think that you're getting good value out of your data and apps, you increase the cluster size, increase your data size, and everything scales automatically upwards. So the newer architecture looks like something like this, right? You have cluster resources, typically of commodity hardware type. You run storage in a central place via HDFS, and then you run Yarn. Applications of different users, queues, framework types, they all run on top of Yarn. And like I've been saying, even though it's a centralized system, there's no notion of, it's a distributed system, right? So it would have been really bad if we separate the silos, put in a centralized system only to think that it's a single point of failure in the organization. That's not the case. You can scale it as you go. Yarn supports a host of applications, frameworks, and then there are meta frameworks which let people write applications without dealing with gory details of Yarn. It also supports varied workloads, batch, interactive, stream processing, graph processing, NoSQL databases, and so on. And it also helps the organization go to large scale, even though you don't want to focus on large scale deployments from the word get-go. So that's the summary of Yarn. So for those of you who are here for the first time, I'm assuming that gives at least some sort of background on what Yarn is. A quick overview of the past, what we've done so far. Yarn is part of the Hadoop ecosystem, so it's a sub-project, which means the releases of Yarn are actually essentially tied to Hadoop's releases themselves. We wrote the first line of code in July of 2010. That was around 5 people. It was an internal project in Yahoo. And then we open sourced it as part of Hadoop because we deemed it as the next evolution of the MapReduce architecture that we already had in the Hadoop 1 project at that time, and that was in 2011. We did the first alpha in 2012 and 2013. We did with the first beta, but these alphas and betas are, they're kind of misnomerish because by that time Yahoo was already running MapReduce on Yarn at scale, with much better efficiency, much better performance, with all the security features, et cetera, that already existed in the Hadoop 1 land. We then, over time, we did a lot of releases, which 2.2 was the first GA release where we said, MapReduce is already working very well. Let's also clean up the API so that newer systems like stream processing, NoSQL database, et cetera, they can start running by using Yarn APIs. And then, over time, every year, we have a couple of releases. 2.3 was the first post-GA release. 2.4 was when we implemented resource manager failover, so we removed some of the single point of failure concerns in the architecture. And 2.5 was a release where we started doing things like REST APIs and timeline service, which I'll talk about a little more. So Jian will now take us through the present.
Yeah, thank you everyone. So that was much for the past. I will be talking about some new features I think the community is currently actively working on. So Hadoop 2.6 and 2.7 were the last 2 major releases where we added a lot of new features. Like in 2.6, we added a rolling upgrade. I'll be talking about each individual feature in more detail in the next few slides. I will just go through very briefly here. So like long running service and no labels, and also in 2.7, we kind of enhanced most of the features that was introduced in 2.6, and also we fixed a number of bugs. And the other major thing we have done is to move the Hadoop to use JTK7. in 2007. So first is rolling upgrade. What is rolling upgrade? Rolling upgrade is basically a way for let people to upgrade your cluster without even losing any of the work. So how does it work? So it basically has, we implement these two features like work preserving restart, IAM restart, and work preserving node manager restart. These two features are basically saying that you can restart your resource manager daemon and the node manager daemon without losing any of the applications and without losing any of the containers that are currently running on the node. So because of these two features, this enables us to do the rolling upgrade, of the Yarn cluster without interrupting any of the applications that's currently running on the cluster. And the overall workflow is like, first, we recommend people to always upgrade the master first because we guarantee the compatibility with the new server, between the new server and the older clients. And there's another big point of this is that we kind of decouple the upgrade of the application framework from the upgrade of the platform itself, which means you can upgrade your application framework, like you can upgrade your MapReduce from 2.6 from 2.8 without even upgrading your cluster. This gives us a lot of flexibility because now you can even run different versions of MapReduce on the same cluster even while the cluster is being upgraded. Here is the overview of the snapshot of the cluster being upgraded. The green ones meaning the green means the new version, and the origin ones means the older version. So here, both the resource managers and both active and standby resource managers are upgraded already to the new version, while the node managers are still stick to the old version, because we always recommend people upgrade the master first, and as well, the application masters and containers are still sticking to the old version. So this enables us to run this AM application masters and different versions of application masters, and also you can upgrade your node managers without upgrading your resource manager. Apart from Yarn, we have, of course, we have a lot of other components across the Hadoop stack, like HDFS and Hive and HBase. So we want, what this means is that we want to upgrade the whole Hadoop stack without losing any of the data, without losing any of the work, without losing any of the applications. So we do have a recommended way for people to upgrade your cluster, like we upgrade the Zookeeper first, and then the core service meaning the name node, the HDFS, and the Yarn resource manager, and some non-core stuff in the stack. So there's a session right after this talk by my colleague Vinod and Sanjay. They will give a very detailed explanation about how can we do an enterprise level upgrade for your enterprise cluster in a rolling fashion. Services on Yarn. So as people know, now we have many services like HBase and Star and Kafka that can be deployed on top of Yarn. Actually, they were able to run even before 2.6 because we have, anyway, this is just one kind of application on top of Yarn. However, there are many other limitations like gaps, like how do we deal with logs. The logs typically, so for short-lived applications like MapReduce, we typically aggregate the logs after the application finish. However, it doesn't make sense for long-running service because they simply do not terminate. They run forever. And also security. If people are familiar with Hadoop security, they kind of based on the notion of token. Application using the token to talk with the various services like node and the resource manager in Yarn. So, but the token itself will expire. It has a maximum lifetime, like 7 days. So how can the application run even beyond 7 days without a valid token? And to take care of all this, we have a Slider project, which I will talk a little bit later, to deal with all this hard stuff. And also we have done something related to fault tolerance of the application masters. Like if you have HBase cluster deployed on Yarn and the HBase master failed, you clearly do not want to lose all your region servers. You can simply restart your HBase master and reattach with the region servers. You don't have to lose everything. And another key point is the service discovery. How is the client even be able to figure out where your application master is running, where your application master is launched by Yarn? How is your client even be able to figure out where your HBase server is? As simple as the question, what is the port number is? So we introduced this feature called Yarn Register Service. It's another service. It's another service alongside with Yarn where we provide a simple API for the user to curate all this metadata information. Here comes the Slider project. This is a partition incubating project. The whole point of this Slider project is to bring your existing service on top of Yarn with very minimal or even no changes. If you look at the graph here, we have all the standardized execution engines like MapReduce, Test, Spark. They already run natively in Yarn, and also on the other side, HBase and Storm and Kafka, they run on top of Slider, which running on top of Yarn. There are also two presentations from Hortonworks and Rocky Field. They will talk detailedly about how to use Slider to move your existing services without even any change or very minimal changes for the developers. Operational and developer tooling. No labels. So as people know, there's often use case that people may want to run a particular type of application only on a particular set of nodes. Like I want to run my HBase on this set of nodes and Kafka on a different set of nodes. One typical way people can do it is simply spin up two separate clusters, one for the HBase and one for the Kafka. That's not gonna scale, and also it's not ideal solution because now you have to manage two clusters, and of course the overall cluster utilization is not as good as a single cluster. So what we have done is we have added this feature called no label, where the admin can say I can apply a label on a node, and the user can say I want to my jobs only on this set of nodes where the label is applied. So for example, on the picture at the bottom, we kind of divide the cluster into separate partitions. We have the partition where no label is applied, which we call default, and the partition B where GPU are applied, and partition C where Windows are installed. People can choose to run application only inside each of the partition. And also the partition itself has two types, exclusive. So the one benefit of this is clearly you now have one cluster to manage separate kind of sub-clusters. And also we added a mechanism, preemption mechanism across the partitions, meaning you can, if one partition is busy, you can even borrow some resources from the other partition, which has much more resources left. And later on, if the partition itself wants to claim those resources back, they can simply preempt the containers. So the two types here, meaning they are exclusive and non-exclusive. Exclusive means I don't want to loan any of my resources to any other partitions. And non-exclusive means it's okay for me to just give this resources to other partition if there's any resource left. However, if I want to use these resources, I get the first priority. Also, there are many other details like queue. How do we manage the capacity of the labels for a single queue? And there's a talk on no labels in Yarn, which we will talk very details about the no labels. Pluggable echoes. So this work is basically to integrate Yarn with Ranger. As you know, probably not people. Maybe some people know about Ranger. Ranger is basically a security management framework. It manages all the echo-related stuff across the Hadoop stack. You can use it to manage your Yarn cluster, Yarn resource manager echo, or use it to manage HDFS echo or Hive, even Hive. So here, what it does is that we kind of refactor, modify the current Yarn resource Yarn authorization model so that it can plug in any kind of echo management framework. So basically, the admin can specify the echoes on the arranger server, and the arranger also has a plugin which sits inside each component. The plugin itself will pose a policy, the echo that is defined by the admin, and then each time the user submits, let's say submit an app, the plugin will intercept the request and run it against the policy that's provided by the admin. The whole nice thing about this is that now you have a arranger to manage all your Hadoop cluster, the whole Hadoop cluster stack. And it also provides a very good way for user to modify and a very standardized view to change the echoes and the stuff. And also, the queue management is now very pluggable because the policy is very dynamic, and the echo policy is very dynamic. People can say, I want this user to be able to access only from 6 a.m. to 6 p.m. Or I can say this user can be accessed only from this single machine. And the admin can choose whatever policy they want through the arranger server. Usability, so we have been working hard to make the YARN framework as easy as possible, because as YARN grows more mature, usability is the key for people to adopt YARN. So some simple questions like, why is my application, I often got this question, why is my application stuck? And what is the locality for my application things? So we are trying every possible way to just dump all this retrieval information on the UI so that people do not need to dig into the logs and figure out the reason. For example, here, the first table shows the outstanding resource request, meaning the request that the application has asked for, but has not yet been satisfied by the resource manager. By looking at this table, you can figure out what are the what are the requests are still unsatisfied. Do I need to expand my cluster, or do I need to go and debug the nodes where the resource request is unsatisfied? Also, some kind of locality info on the segment table. People may ask for 10 containers on the node. However, it may only give you 5 containers on this node, and then give 5 containers on a different node. How will you be able to figure out this info before? You can only figure out this from the logs. Now we simply dump this table on the UI. You can see the locality info, and this is important for some locality-intensive applications like MapReduce, because if the locality is bad, you spend much more time on moving the data around. Also, there are many other stuff, like what is the health day of my scheduler over time, and what is the currently running containers for my app. That's pretty much for the present. I will talk a bit about the future, some exciting features we have been actively thinking and working on. Procure policy-driven scheduling. As people know, today we have 2 types of schedules, capacity scheduler and fair scheduler. We cannot run 2 schedulers at a time because that's a limitation by the current structure. So people may want to say, so currently, fair scheduler, the primary difference between these two schedulers is that applications running in the capacity scheduler is kind of served in a first in, first out order. And the applications in the fair scheduler is kind of served in a way that each application over time gets an equal share of the resources. Like there are many, because there are many kinds of workloads that now are deployed on YARN. And like this example, the root queue, under the root queue, we have an ingestion queue for, let's say for the ingestion job, and the batch processing queue, and for the batch processing jobs, and ad hoc queue for the ad hoc queries. It makes sense because previously there's only one scheduling algorithm across the cluster. We cannot run particular scheduling policy for a particular queue. Now we have modified YARN queue scheduling policy so that we are able to plug in any kind of scheduling policies into any queue. That means we have one scheduling algorithm per queue. This is very flexible, not just in terms of a workload, supporting various kinds of workloads. It's also useful if we want to add more features. Like tomorrow, we will add an application-based priority scheduling policy. We don't have to do major surgery in the code implementation, we can simply implement this interface and then run it. Reservation, this work is primarily done by Microsoft and some other community folks. So the whole idea behind this is that I want to reserve some, let's say some use case, I want to finish my job by 6 a.m. tomorrow. I want to reserve some resources from 6 a.m. to 10 a.m. and then another set of resources from 1 p.m. to 5 p.m. To satisfy this kind of requirement, that's what the reservation system does. The reservation system basically either accept or reject such a request. If it accepts the request, it will, the resource manager, the Yarn resource manager schedule will automatically adjust the kind of shrinking the queue size to free up more resources or expand the queue size to get more resources so that your job SLA is matched up, it's guaranteed. And also there's another talk, the Microsoft folks will talk in very, very more details about the reservation scheduling. How can you use it to match your workload? Yeah, that's much for my side. My colleague Vinod will talk a bit about container localization.
Thanks. So container applications, right? A lot of, in the past couple of years, there's a huge momentum. There's a revolution going on side on how you package applications, how you run them, et cetera. One of the candidates is Dockers. And on the other side, you still want to be able to run your apps which are containerized on a shared cluster, thereby utilizing your cluster, not just for this type of apps, but everything else that Yarn is promising you, right? So we're looking at integrating these two ecosystems by giving you an ability to run Docker containers on top of Yarn. There was a talk just before this one. In case you've missed, please go through if you can. But the fundamental use cases that we're trying to solve here are multifold. One, I have an existing MapReduce or a Thales or a Spark application that I want to run inside a Docker container, be it for software isolation, because Docker gives you a very good way of packaging your individual containers, right? So that's one of the use cases. The other use case is I have an existing service that I want to bring on top of Yarn. I have Docker containers that are already built for running, say, MySQL or Tomcat or what you will. So that's the second use case. There are lots of these use cases where people have already built images. They have an existing container format. They want, at the same time, they want to run it in a shared multi-tenant cluster, getting all the advantages of Yarn. So that's one of the areas that's being actively worked upon. We are targeting a bunch of things in 2.8. We hope you find a good use of that. The other important dimension to Yarn that we are actively working on is resource isolation. Yarn always had a pretty good story on memory. A couple of years or three years ago, we added CPU support. But the harder problems of disk isolation and network isolation are still not solved. And this is where we're spending a lot of time. We want to seriously differentiate ourselves from the rest of the resource management systems. Disk isolation and network isolation is not simply putting your task or your service in a container. It's also about giving a very good model for the end user to reason about how your resources get utilized in a shared cluster. Be it, take disk for example, right? In a typical Hadoop cluster, these are all the things that are happening on a single machine. You may be running a data node, which is doing I/O directly on behalf of the users, either reads or writes. Node managers do a lot of logs, localization, shuffle, et cetera. Region servers maybe doing short circuit read to read data on the local machine. Map task and reduce task, they do a lot of spills, so they write information, read back information. So a lot of things happening on an individual machine. So it's not enough to just say that I'll put my MapReduce task or a region server in a container. You also have to reason about how I/O is happening, maybe even remotely, right? So eventually you may end up wanting to run HDFS itself on top of Yarn and have isolation properties inside HDFS so that individual users can reason about I/O irrespective of whether it's a local I/O that they're doing directly or going through another system like HBase or HDFS. So what we have done so far is we have done the easier part, which is once things are running already on top of Yarn, give equal share so that they all behave well with each other. the next step is the part that I kind of mentioned about give a very good user model on how they can ask Yarn the resources that they want, and give good policies in terms of scheduling. Similarly, network is also a problem. There are a lot of things happening on a machine. You have data nodes, node managers. If you're running Storm also on the same cluster, MapReduce, et cetera, they're doing lots of things. They're reading data from a local container, remote container, local service, remote service, et cetera. They might also be pumping a lot of data through the network. And even there are multiple dimensions. Is it incoming network or outgoing traffic, or is it my local network adapter, or is it the top of the rack switch? There are lots of dimensions, and it's kind of a hard problem. So even there, we have taken the first step in kind of saying, if you're running on top of Yarn, we'll give you equal share for outbound bandwidth. Controlling incoming bandwidth is a much harder problem. The next step is basically giving a very good user model in terms of how you can ask what you want and schedule apps accordingly. Timeline service, one of the important problems that we've seen in so-called multi-tenant clusters is people run jobs. While the jobs are running, they want to figure out what's happening. After the jobs have finished, they want to figure out what's happening with their apps. They also want to figure out what's happening with their cluster while these apps are running, et cetera. So to answer questions like, what happened to my app, where did my containers run, how many failures, how many slower tasks, et cetera, we have implemented this generic service called timeline service. What we have today is a level DB-based implementation. It's not scalable. It has limited scalability and availability characteristics, but we have integrated this with things like MapReduce, Thais, and Hive to understand what sort of questions we can answer with a system like that. The Timeline Service 2.0 is an effort, it's a community effort, primarily led by our friends at Twitter. What they're really trying to do is take the Timeline Service V1 beyond what it exists today, have better scalability, better availability, and also ask and answer lots of more questions. Increasingly, analyzing what's happening in a Hadoop cluster itself is becoming a big data problem. So what we're really trying to say is pump in all of this information in a scalable storage system like HBase, and then ask questions. There's a lot of interesting work that's happening in this space that we hope will see the light in the 2.8 release. Usability, again, this is tightly coupled to what information that we can store and track. Once we have the next generation timeline service, we can answer very complicated things like, why is my application slow? This is one of the most common questions that people, users of a Hadoop cluster ask about. And the conversation between the user and admin always is like, oh, it never got slowed down. You didn't have enough information, et cetera. Is the application slow? Is my cluster slow? What happened to my clusters over time? Do I have to increase the capacity of my cluster because it's always running full, et cetera? These are the kind of things that we want to answer. There's a lot more. Yarn is a huge community project. People are working all over the world on tons of things that interest them. So no presentation that runs for 40 minutes can cover all of it. So I try to pack many of these features on this one slide. One of them is application priorities. We still don't have a notion of prioritizing one application over another. In terms of scalability, Yarn, we originally designed it to run on anywhere around tens of thousands of nodes. Nothing in real life really stretched Yarn to that scalability yet, but our friends at Microsoft are leading an effort to scale Yarn using federation to hundreds of thousands of nodes. We don't have a good statistics collection on each machine to figure out what a container is doing, what the node is doing, et cetera. So we're trying to unify that. There are lots of scheduling features where it's an interesting blend of researchers wanting a bunch of things and real-life use cases looking for solutions. Some of them include node anti-affinity, where I'm running a service, I only want one copy of it on each machine. Gang scheduling, where I want to say, I don't care where you run all my 10 containers, but run all of them together at the same time. Dynamic utilization. Today, the placement in Yarn is more of a reservation. You say, I need 4 GB RAM and three CPUs. We just go and run you there. We don't care whether you've used all of that or not. We just assume that you're making your reservations right. So there's a parallel effort. Again, There was a research paper by some friends in Microsoft Research to basically pack more and more containers depending on their actual utilization. Prioritization of queues, admins typically want to do maintenance tasks time and again, and at that time they want to say, I want the absolute priority. I don't care about what the organizational policies are. I'm the super important user at this point of time. Lots more we want to consider. We are moving towards running HDFS on Yarn, and it's not an easy task. There are lots of very difficult challenges to take care of. We want to move to a global scheduling model. Today, the scheduling is based on a per node local optimal algorithm. A node comes in, we try to fit the right application there, and many times the local optimum doesn't tend to be the global optimum. I think that's the last one. We have about 5 minutes for questions. Oh, I joined Arun in writing a book on Yarn to introduce you to what it is about, etc. So how many of you have slept? That's the first question. You slept?
I have not.
Go ahead, Andy.
I have a question for the resource scheduling.
Mm-hmm.
So I think the early days we have memory, and now we have a CPU. In the slide here, you talk about the network, right?
Yeah.
So the question is so let's say, as the example you had, let's say if you have a cluster with, let's say you have a GPU node. So then let's say, can you declare a GPU just another type of resource? And then at the end, once you go down that path, then going to be, say, a particular device ID for a GPU belong to me, so I just wonder.
Yeah, that's an interesting question. So a colleague of mine, Varun Vastev, today Yarn already has a notion of an extensible resource, but it's not completely exposed to the end user as an extensible resource mechanism. So anytime we want to add a new type of resource, be it network or disk, what we have seen is it's not an easy thing to do. So what he's trying to do is make that really an extensible vector so that an admin could actually plug in a bunch of resources from outside of Yarn without code changes and use the same scheduling policies, algorithms that we have. I believe there's a Jira for this, but yeah, that should let you do what you're really looking for.
What's the timeline?
Timeline. We want everything right now. I don't know. So we'll target for the next few releases, yeah.
Hey, Vinod.
And Jian, he can also answer some questions.
Hey, Jian. So when you start adding other resources to that vector besides memory and CPU, how does that affect the dominant resource calculator?
Yeah, so the more resource types you add, it really affects how you want to do scheduling, right? For memory and CPU, we have done a loose kind of dominant resource. What it really does is bottleneck-based resource, right? On a machine, if CPU is the biggest bottleneck, then we schedule based on that. So as we add more and more things like disk and network, it'll continue to be like that. But we are pursuing other policies too, where once you move to a global scheduling kind of model, you can pack things in a little different fashion, even if you're handling dominant resource. It's kind of a very elaborate question, so I'm not sure if I answered it good enough.
Hi. Sorry, from here.
Okay, there are lots of people.
One by one, yeah. Quick question. How do you compare Yarn with Mesos?
That's a very good question. So we've always focused on data for a long time. We have done a good job, and like I said, there are lots of challenges that we think are still not solved even on the data front. But increasingly, we are also moving to a place where we run arbitrary services. And for us, it's a complex, scheduling both types of workloads is a complex thing. So we are already on that way. With Mesos, fundamentally, you focused on the services land. It makes onboarding of new services very easy. But moving beyond, exposing things like org level policies on how you share resources, et cetera, that they have gaps on. So there are gaps on both sides. We are playing in the same field, et cetera. But again, this is a elaborate question that needs more answering. But that's the current state.
Hello.
Let's do one here.
I have a question sorry. I have a question specifically to your rolling upgrade. So you mentioned that when you're upgrading the node manager, then I'm curious, like whether the application master is still running when you rolling update the node manager or not,
Right.
and also the containers. And if that's the case, then you also mentioned when you rolling update your resource manager, you're recollecting basically you recover the state by querying all the node manager. Then what if one of the node manager, when you're upgrading, it dies? It never comes back.
You want to take that?
Yeah. So there are many events when you upgrade the cluster. You will see some nodes are not coming back, and some maybe even some data persistent in the storage are missing. So to your particular question, what if the node is not coming back? We have a kind of a timer inside the node in the resource manager. So if the node does not come back within a threshold, we will consider this node as dead. But as you know, we have a few gaps, right? We are not remembering the nodes before restart. So we are typically losing the node before restart after the resource manager restart. So we have added a simple mechanism to determine whether we should consider this node as dead or not.
One more question. So my curiosity is along the line that the resource manager, you say, is collecting the state from the node manager. But
Right.
the node manager, if the node manager dies, then who is the source of truth of the state of the whole cluster?
So it's actually twofold, right? When a cluster is coming back after rolling upgrade, there's a session immediately after this. I also have to run to the talk, so I can definitely answer that question there. Do you mind? All right.
Hello. Okay, great. So today, currently, Yarn aggregates logs by jobs, right? So it's like a job ID. Are there any plans on also aggregating logs by time?
Yeah, so today we support aggregating logs periodically for the long-running service, which I specifically talk about. Because for long-running service, so typically for MapReduce, we aggregate the logs after job finish. For the long-running service, there's a configurable amount of time that you can aggregate the logs. And also, you can aggregate the logs based on some regression matching expression. You can say, I want to aggregate the logs, which ends with start.xml or something, yeah.
So you can periodically aggregate them too. I guess this is the last question before we get kicked out. Okay, we don't have time. We'll take this offline. Thank you, guys.